When we talk about solutions, we often want to know what the concentration of the solution is. How much solute is there present? And there are lots of ways we can talk about the concentration of a solution. In this particular chapter, we're going to talk about molarity. Molarity is symbolized with a capital M, and molarity equals the moles of solute that are dissolved per liter of solution. So we could write an equation and say that molarity equals moles of solute per liter of solution. So let's look at some examples. This question says, what is the molarity of a solution made by dissolving 10.4 grams of solid sodium hydroxide to 1.75 liters of solution? All right, well, we want to calculate the molarity of the solution. Molarity equals moles of solutes per liter of solution. And sometimes problems are easy enough where they give us the moles and they give us the liters and we just plug it in and we have our molarity. But here it doesn't give us the moles of solute. It tells us how many grams we have. So our first step is going to have to be to convert grams to moles. Then we can plug our numbers into our equation. 10.4 grams of sodium hydroxide. We need to get that to moles of sodium hydroxide. So 1 mole of sodium hydroxide is the molar mass for sodium hydroxide. So we look that up on the periodic table and we get 40.00 grams of sodium hydroxide. We want 3 digits in our answer, so when we plug this into the calculator, we're going to get 0.260 moles of sodium hydroxide that we're going to dissolve in 1.75 liters of solution. So now we can calculate our molarity. We're going to plug in 0.260 moles of sodium hydroxide dissolved in 1.75 liters of solution, and that's going to give us a 0.149 molar solution. Or there are 0.149 moles of sodium hydroxide in every liter of this particular solution. But rather than saying moles per liter, we shorthand it as saying molar. So 0.149 molar. Now we can solve for any of the variables in the particular problem. It's not always that we're trying to find out what the molarity is. So this question says how many grams of magnesium bromide, so let's write our formula first. We know magnesium is a +2 and bromide is a -1, so there's our formula, are required to make 1.5 liters of a 0.25 molar solution. All right, well, when we look at our equation, molarity equals moles of solute per liter of solution. In this particular problem, we're given the molarity and we're given the volume. So we can calculate the moles of magnesium bromide we need to make the solution. Moles will equal the molarity times the volume in liters. So we'll take 0.25 molar times 1.5 liters. Now if that was in milliliters, we'd have to convert it to liters first. We only want 2 digits in our answer this time, so 0.38 moles of magnesium bromide. But the question doesn't want to know how many moles of magnesium bromide because that's not something we can measure in lab. We're going to have to convert moles to grams. So we'll have 0.38 moles of magnesium bromide for every 1 mole of magnesium bromide. We need to know what the molar mass is, which is 184.1 grams. 184.1 grams. We're going to round to 2 digits, so we're going to get 70 grams of magnesium bromide. So what that means is if we want to make this particular solution, we would mass out 70 grams of magnesium bromide, add it to a volumetric flask, and add water until we have 1.5 liters total for our solution. So let's take a look at that. What we have here is what's called a volumetric flask, and it's used to make solutions with specific volumes. So in this case, we would measure out 70 grams of magnesium bromide and add it to our volumetric flask. Add a little bit of water, make sure that we wash any magnesium bromide off the sides of the volumetric flask. Swirl that flask around until all of our solute dissolves. Then we would add a little bit more water, make sure that there's no magnesium bromide on the side, swish it around until it's all dissolved, and then finally we would add up to our volume marker, or our calibration mark, and that would give us exactly 1.5 liters of a 0.25 molar solution. And volumetric flasks come in all different volumes depending on what the solution is you want to make. So let's solve for the third variable. How many liters of solution must be made in order to make a 0.50 molar lithium nitrate solution with 25.0 grams of lithium nitrate? So again, we've got that molarity equals moles of solute per liter of solution. This time we're given the molarity. We're not given the moles, but we can calculate the moles from the grams, and we want to solve for liters. So first, we'll take the 25.0 grams of lithium nitrate and convert that to moles. So 1 mole of lithium nitrate is 68.95 grams of lithium nitrate. We're getting that off the periodic table. We want 3 digits in our answer, so 0.363 moles of lithium nitrate is what we're working with. Well, if molarity equals moles per liter, and we want to solve for liters, we're going to multiply both sides by liters and divide both sides by molarity, and that'll isolate our liters variable. So liters equals moles over molarity. So 0.363 moles divided by 0.50 molarity, and that will give us 0.73 liters, or if we multiply that by 1,000, 730 milliliters. So if we measured out 25 grams of lithium nitrate and added it to a volumetric flask that's 730 milliliters and added water until it all dissolved, we would get a 0.50 molar solution. Now, when we talk about electrolytes, having technical difficulties again.